Alright, welcome back. In this video we're going to go over some more geometry, starting with coordinate geometry, and that's going to help us to find the midpoint and distance. We're going to go over Pythagorean theorem and also some area and perimeter formulas for common shapes. So to start off today, let's go over some coordinate geometry. So this is the coordinate geometry system. We have an x-axis and a y-axis. And every point, we can give two coordinates, an x value and a y value. So we write them in parentheses like this with a comma. And the first number is going to be our x coordinate. That tells us if we go to the left or to the right. And the second coordinate is the y coordinate, and that's going to tell us if we go up or down. Where the x and the y-axis intersect, that is our origin. That's the point 0, 0. And so if we have a positive x, 5, 3, that means that we're going to go to the right 5 spaces, 1, 2, 3, 4, 5, and then the 3 is going to tell us to go in 3 in the positive direction, 1, 2, 3, and we end up right there at 5, 3. Whereas if we have a negative x value and a negative y value, like negative 4, negative 2, then negative 4 is going to tell us to go to the left 4 spaces from the origin. We always start back at the origin, 1, 2, 3, 4, and then the negative 2 is going to tell us to go down 2 spaces, 1, 2. So negative 4, negative 2 would be in the third quadrant. I labeled the quadrants here. They have Roman numerals, so up here in the top right is quadrant 1, quadrant 2 is in the top left, and then we go down here counterclockwise, quadrant 3, and then quadrant 4. You don't have to remember the quadrants, but it kind of helps us to figure out where these points are going to go. So let's take another example. What if I said, where is the point 2, negative 4? Which quadrant do you think it's in? 2, negative 4. Well, if you said the fourth quadrant, you would be correct. So we would go to the right 2 spaces, and then down 4, 1, 2, 3, 4. And then right there, that would be our point 2, negative 4. What if I said the point negative 2, positive 4? Which quadrant would that be in? That would be in the second quadrant. Negative 2, 4 tells us to go left 2 and then up 4. So that would be right there. So that would be the point negative 2. Oops, let me just get that back on there. Negative 2, positive 4. And of course, we could have a point that's on the x or the y-axis. So like if I go to this point right here, what would the coordinates be for that? Well, that's to the right, 1, 2, 3, 4, 5, 6. And it's not going up or down, it's on the x-axis, so that would be the point 6, 0. So you should be able to plot points, and given a point, you should be able to give the coordinates of them. And we're going to be using this for several different types of formulas throughout the rest of this course. Started with midpoint and distance today, but then also when we start graphing lines, when we start talking about algebra. So this is going to be very important that you know how to plot points and how to find points on the coordinate system. And again, the first coordinate is our x coordinate. That tells us if we go up or that tells us if we go left or right. And the second one is our y coordinate. That tells us if we go up or down. Here's another slide showing the same thing with some additional points. And so first off, what we want to do is to find the midpoint. So given any 2 points, say, given a point here and a point here, we want to find a point that's going to be halfway between them. We can connect these with a line segment. So the midpoint is going to be some point that's between them halfway along this line segment, going from endpoint to endpoint. And so we have a formula for that. And I'm going to show you how to do it with the formula, and then also how to just do it graphically by looking at the picture. So given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, these little subscripts here just tell us that these x and y's come from the first point, and these over here come from the second point. To find the midpoint, what we're going to do is we're going to take the average of the x's, so we're going to add those, divided by 2, and we're going to take the average of the y's, add the 2 y coordinates together, and divide it by 2. And that will give us the coordinates for our midpoint. So another way you could do this is just by looking at the graph. And so let's find the midpoint here on this line segment. What I like to do is I like to draw a triangle. So notice how this kind of forms, if we make a straight horizontal line and a straight vertical line to try to connect these to make a triangle, we could get a picture that looks sort of like this. And I'm going to draw the horizontal in red and the vertical line segment in blue. And so if I notice going across here, this is two spaces. So half of that would be 1. And if I look at how far up and down it's going 1, 2, 3, 4 blocks. Half of that would be 2. And then notice that where those two are going to meet, that's going to be our midpoint. So if we go halfway across and we go halfway up, right there is where those two halfway points are going to meet, and that's going to be our midpoint. Now the midpoint here, we'd have to give the coordinates of it. So to give the coordinates of this purple point, it's 1, 2, 3 to the left, so that's -3, and then it's up 1 from the x-axis. So the coordinates would be -3, 1. So that's how we can do it visually without even using the formula. We can just make the triangle and find halfway along the x and halfway along the y, and we've got our point. And notice that that midpoint should be on the line segment, and we should be able to see that it is exactly halfway along the line segment. Now, if we were doing this with the formula, here's how we do it. So we got the picture here. We need to get the coordinates. So the coordinates of this point here would be negative, let me just write it down here. The coordinates of the bottom left point would be -4, -1. And then the coordinates of this point up here would be -2. And then it's got a y coordinate of 3. All right, so let's pretend we don't know what the midpoint is. We're going to use the formula. So remember what the formula says. The formula is going to be the average of the x's, add up x1 and x2, divided by 2, add up the y's, divided by 2. So every time I'm using one of these formulas, what I like to do is I like to label my points. So I've got the points written out here, the coordinates. Here's the x and the y, here's the x and the y. And since I wrote this one first, I'm going to call it x1, y1. And this one I'm going to call it x2, y2. So that now I know exactly what to plug into the formula and where, and then what to do with it. So we've got our formula. We're going to add up the x's. So we've got -4 plus -2. We're going to add those up. We're going to divide that by 2. And then we're going to do the same for the y's. We're going to add up the y's, -1 plus 3, and divide that by 2. So remember, order of operations, we got to add the top first. This gives us -6 over 2, which is going to give us -3. And over here we have 2 over 2, which is going to give us 1. So again, we find that the midpoint is -3, 1. And now when you do this formula, if you've got the graph here, check to make sure that that point actually makes sense. So go ahead and plot it. -3, 1, there it is. It's on the line segment, and it looks like it's halfway along the line segment. So that is our midpoint. If you've got a horizontal or vertical line, that makes it a little bit easier because you're just going in one direction here, and you can just count the spaces. 1, 2, 3, 4, 5. Now 5 is not an even number, so we have to kind of split that into 2 here, and we're going to have a half. And now we want the coordinates of this point. And what would the coordinates be? Well, this time it's going over a half to the right and down -4. So that one, if it's a horizontal or vertical line segment, it's easy to do just by the picture. The formula will still work. And here we got a half and -4. Okay, let's do it for number 3. Again, we can do it by the picture. It looks like the midpoint, if we draw our triangle, this time I'm going to draw the triangle going on this side. And count up the spaces going up. 1, 2, 3, 4, 5, 6. So 6, we can divide that by 2. We get 3 on each side. Going across, it's 3. So that one, We're going to have a fraction, so that's a half, 1.5 on each side. And look at where those cross. They're going to cross right here. So that should be our midpoint. But let's also practice using the formula. So I'm going to erase this. And what are the coordinates for this point at the top right? So this point is 0 because it doesn't go to the left or right, and then 1. And then this point down here looks like it's -3, and it's going down 5, so -5. And again, we're going to use our formula for midpoint. Let's label these guys x1, y1, x2, y2. Again, the ordering here doesn't matter. I could call this one x2 and y2 and this one x1 and y1. That doesn't matter. We just want to make sure we're keeping our x's and y's straight. So we're going to add up the x's, 0 plus -3, divide that by -2, and we've got 1 plus -5. We're going to divide that by 2, simplify our answer. Here we have -3/2, and here we're going to have -4 divided by 2, which is going to be -2. So we could write it this way. So this is one way to write the midpoint. You could also write it as -1.5 as a mixed number, -2. That would be another way to write it. Or, let's put that in parentheses. Or we could write it as -1.5, comma, -2. So we got 3 different ways we could write it with this fraction. So that is the midpoint formula. So here we have, it's pretty easy when you have the graph and you have the points, and we can just look at the picture, and even, you don't have to use the formula. Gets a little bit trickier when we don't have the picture and say we've got just points like this. Now you could go to your graph paper, plot the points, and do the same thing, find the midpoint graphically, but let's practice using the midpoints formula on a couple of these. So this guy, we're going to label x1, y1, x2, y2, add up our x's. So here we've got 8 plus 1, we're going to divide that by 2. We add up our y's, 10 plus -2. We're going to divide that by 2. Simplify. Here we're going to have 9/2. And here we're going to have 8 over 2, which is 4. So we got 9/2, comma 4. And again, we could write this 9/2 as a mixed number or as a decimal 4.5. It's that easy. That's the midpoint. That's all you have to do. Okay, we'll do one more here. Let's try 11. So this is x1, y1, x2, y2. And again, we're going to add up the x's. So we got -3 plus 7 divided by 2. And we've got -9 plus -5 divided by 2. This formula helps because then we don't have to graph it, and we know what the midpoint is. Makes it faster. So we got -3 plus 7 is 4. 4 divided by 2 is 2. And -5, -9 plus -5 is -14. Divide that by 2, we got -7. So 2, -7 would be our midpoint for number 11. And I'll leave the rest of these and what you do in your workbook as extra examples. All right, the next thing I want to go over is the Pythagorean theorem. And the Pythagorean theorem is going to work for right triangles. And it's going to allow us to solve for the sides of a right triangle. So how do we know it's a right triangle? Well, remember, we're going to look for this little box here. All right, that's telling us that we've got a 90-degree angle. We've got a right angle. And remember when I went over some of the definitions for triangles, that a triangle has legs and it has a hypotenuse. The hypotenuse here is the longest side. You're going to notice the hypotenuse because this right angle is kind of an arrow that points over to the hypotenuse. The hypotenuse is always straight across from the right angle. So this side over here is our hypotenuse. And we're going to label that C. So when we have the Pythagorean theorem, it says that a squared plus b squared equals c squared. You've probably seen this formula before. It's pretty famous. And the important part here is that A and B are interchangeable. It doesn't matter. I could call this A and I could call this B. That doesn't matter. But what matters is the C has to be the hypotenuse. A squared and B squared, we can interchange those. But C, we have to pick that out first. That's going to be our hypotenuse. And this formula is going to allow us to solve for a third side if we know any of the two sides. So here's some examples. Number one, we've got 12 miles, 5 miles. We've got to find x. Now we can see that x, it should even look like x is the longest side here. It is the hypotenuse. We've got our right angle. It's pointed over here to our x. So I'm going to call that my C. And label these guys A and B. Again, it doesn't matter which one's which. Pythagorean theorem says that a squared plus b squared equals c squared. We're going to plug these in. So I've got 12 squared plus 5 squared equals c squared, or x squared. We'll just put our x back in here. And I want to solve this for x. So what do I have to do? Well, I've got to simplify everything here on the left side. So I've got 12 times 12 is 144. 5 times 5 is 25. Then we have to add those together. We get 169. And now that's not our x here. That's x squared. Of course, that would be too big. That answer doesn't make sense. So how do we get just x instead of x squared? Well, what's the opposite of squaring something? It's to take the square root. So it's this symbol here, the square root symbol. So you should see that on your calculator or on Desmos if that's what you're using. And the square root of 169 comes out evenly to a 13. So here we get a nice integer answer of 13. And notice that since it's the hypotenuse, it should be the longest side. So it has to be bigger than 12. Okay, for number 2, again, we have to find the missing side. Here's x that we want to solve for. Here is our right angle. And the first thing to do is to find C and to label that. So C is across from the right angle. So the 10 here is going to be our C. And A and B are, we'll just label those so we can plug them in. We've got A squared plus B squared equals C squared. That again is our Pythagorean theorem. We're going to plug in the numbers that we know. So for A, we're plugging in our x. So we got x squared plus 8 squared equals 10 squared. And simplify, 8 times 8 is 64. 10 times 10 is 100. And we have to get the x squared by itself first. So we're going to subtract 64 from both sides to get x squared here. And we got x squared is equal to 36 after you take 64 away from both sides. And again, that's not our x yet. We have to do something else. We have to take the square root. And that gives us what times what to give us 36. Of course, here it's going to be 6. So we got x equals 6. Now, again, that answer should make sense. If you look at the picture, it looks like the x side here is the shortest side. So we would expect that whatever number we get here is smaller than 8. When I'm solving math and geometry problems, I always try to think, does this answer make sense? Does it look like it works in the picture, if the picture is drawn to scale? For number 3, we have another right angle. So notice that the right angle here is not always in the same position. Here it's at the top, but the right angle is always going to point to the hypotenuse. So here the hypotenuse is going to be our x. And that means now we've got A is 7.3, B is 7.9. And I'm just going to plug them in right away. We got 7.3 squared plus 7.9 squared equals x squared. And we've got to plug this into Desmos. So, or to your graphing calculator. And into Desmos, you can just plug this whole left side in here right away. So 7.3 squared gives 53.29 plus 7.9 squared gives a total of 115.7. And that's equal to x squared. And now I want to take the square root of that. So what is the square root of 115.7? Well, it comes out to 10.756. It's going to be an irrational answer this time because it doesn't come out to a nice square root. But notice up here in our directions it says round to the nearest tenth. So we're going to round this to one decimal place to 10.8. So we get an answer of 10.8. Okay, number 4. Here we have a side of 8. Here we have another leg that we have to find. Here we have 10.9. Which side is the hypotenuse? That's right, the 10.9 is going to be our hypotenuse. And x here is a leg. So we're going to have x squared plus 8 squared is equal to 10.9 squared. Now let's just estimate. What do you think x is before we even solve for it? It looks like it's pretty close to 8, maybe a little bit longer, but it's going to be pretty close to 8, maybe 9, I don't know. So let's figure it out. It should be shorter though than 10.9. So let's plug this in. And we've got x squared here, we've got 64, and on the right side I've got to square out 10.9 squared. That comes out to 118.81. Make sure you're not rounding until the very end, and I'm going to subtract off 64 from that. So take 64 away, take 64 away from both sides. That's going to give us x squared is equal to 54.81. And then we're going to take the square root of 54.81. So that gives us x equals square root 54.81. Oh, it's a little bit shorter than 8. It is 7.4 if we round it to the nearest tenth. So we were pretty close. It's close to 8. So it's actually a little bit shorter here. So we got 7.4. And that's how we solve for missing sides. Now, while we're talking about this, let me bring up Desmos here. So give me a second to switch screens. All right, so here is Desmos.com, our free online graphing calculator. And like I said, you can download this as an app on your phone or other device. Or you can just go to this website. And remember, we had some things where we were doing like 8, I don't know what it was, 7.3 squared. And if we bring up this little keyboard, you can get the square like that. You can add on, another number. And if you use Shift 6, that will also allow you to get an exponent like that. You can even do more things to it. You could put the square root and then copy and paste this and move this all on the side. So the important thing here is that this is down here is where the square root is. Pi is also here. We're going to be using pi in this lesson as well. So you got our exponents up here. This is what you're going to use to square. This is what you're going to use to square root. And here is pi. It's also got some other functions here. Notice it's got some functions down here for GCD and LCM, so that might be helpful for you as well. And let's go back to the lecture. All right, in this next section, we're going to find the distance between 2 points. And there is a formula for this, but I'm going to show you how to do it without the formula first by just graphically and using our previous knowledge. And then I'll show you the formula, because the formula for this one's a little bit hard to memorize, and it's a little bit more complicated than the midpoint formula. But I think we can get around it. So first off, if it is a vertical or horizontal line, like we have for number 9, that makes it easy to find the distance between 2 points because we can just count the spaces. 1, 2, 3, 4, 5. It's 5 blocks away. So the distance from one to the other, or the length of this line segment is 5 units. And the same would be true if we have a horizontal line that goes like this. Then we could just count the spaces, 1, 2, 3, 4, 5, 6, 7. So this one would have a distance of 7. It's a little bit more complicated if the line segment is going diagonally, because we can't just count off the blocks, because where does one block end and one block begin? It's hard to tell. So I mean, you could try to estimate, and maybe you do try to estimate 1, 2, 3, 4, 5, 6, and try to evenly space these 1, 2, 3, 4, 5, 6, 7, 8, 9 maybe. So you might guess that it's 9, 8, 9, 10, but there's an easy way to find this. And just like with midpoint, when we're doing it graphically, this one I'm going to turn it into a triangle and add on a horizontal and a vertical line here to make it into a triangle. And what kind of triangle does this give us? And how is this going to help us to find the length of this side? So how can I use that to find this distance? We want to find this length here. Call that D, capital D. Well, what we have here is a right triangle, and we just said that if we know the lengths of the legs for a right triangle, we can find the length of the hypotenuse. D here happens to be the hypotenuse for a right triangle. So after you draw this picture, all you have to do is count the spaces, 1, 2, 3, 4, 5, 6. So this has a length of 6. Count up the spaces this way, 1, 2, 3, 4, 5, 6, 7, 8. Has a height of 8. So now we can use what? The Pythagorean theorem. So we've got 8 squared plus 6 squared is equal to D squared. And we already did this before. We got 64 plus 36 is equal to D squared. That comes out to 100 is equal to D squared. So D comes out to 10. Oh, wow. So again, we can't just count it. We have to calculate it, but we can calculate it by turning this into a right triangle and using the Pythagorean theorem. So all of these we can turn into a right triangle when we've got the picture here to find the distance. So for example, for number 11, we're going to turn this into a right triangle. And again, it doesn't matter which side you draw the triangle on, if you make it on the top or the bottom, just pick one. So here I drew the triangle on the top. Count up the spaces, 1, 2, 3. So this is 3, and this is 1, 2, 3, 4, 5. And here, this is D. We've got A squared plus B squared is equal to C squared. And you could even skip a step here and just say D is equal to the square root of A squared plus B squared. Or if you want to call it X squared plus Y squared, you could do that as well, because one side measures the horizontal distance, the other side measures the vertical distance. And so we can plug these in, and we've got the square root of 3 squared plus 5 squared. We can simplify that. It comes out to 9 plus 25, the square root of 34. And again, if you're doing this in Desmos, you could just type it in like this, the square root of 3 squared plus 5 squared. And that comes out to 5.8. So our distance here is 5.8. Okay, so anytime we want to find the distance, we can use the Pythagorean theorem. Make your right triangle, count up the spaces. So for this one, this is the triangle I can make. Count up the spaces going across, 1, 2, 3, 4, 5. And then here I have 1, 2, 3, 4, 5. So my distance is going to be 5 squared, square root of 5 squared plus 5 squared, which is the square root of 50, which is going to come out to 7.1. Now you might be like, but isn't there a formula like the midpoint formula? There is. We're going to show you the distance formula here. let me show you the distance formula that we have for this. And like I said, the distance formula is a little bit harder, a little bit more complicated, but it is the Pythagorean theorem in disguise. So here the distance formula is going to be d equals, and then we've got that big square root. And remember how I had like the square root of a squared plus b squared? Well, here it's x1 minus x2 squared plus y1 minus y2 squared, like that. Some people might have these switched too. Maybe they put it as x2 minus x1, y2 minus y1. Well, let's do it like that, I guess. The order here doesn't really matter because we're just subtracting them and we're going to square it. So it's going to be positive. And same thing here. We just got to make sure the x's go with the x's and the y's go with the y's. This is going to tell us how far apart it is horizontally. This is going to tell us how far apart it is vertically. And we square it just like we did with these pictures. So let me go back here and pretend we don't know the distance is 5.8. So here I've got a point of negative 3, 0. And I've got a point over here that is at 2, 3. And then I would label it. So label this guy x1, y1, x2, y2. Again, just like with midpoint, the order that I label them doesn't matter. I could call this the x2, y2, and this one the x1, y2, or y1, doesn't matter. As long as you are consistent. So this is our first point, this is our second point. So we're going to plug them into our distance formula. And I've got parentheses here, 2 minus negative 3. We're going to square that, plus, so that's the x's, 2 minus negative 3. And then the y's, y2 is 3 minus 0. We got to square that. Make sure that this is in parentheses. Make sure you do the inside first. So here I'm going to have 5 squared. Here I'm going to have 3 squared. And again, we're going to come up with the same thing. This is going to be the square root of 34, which we already said is 5.8. Show you one more using the distance formula. So remember we said that this distance is 7.1. Let's prove it using the distance formula. So for number 12, again, I've got 2 points. The one here is negative 2, 2. The one here is 3, negative 3. And we're going to use our distance formula. Let's label these guys x1, y1, x2, y2. And we've got 3 minus negative 2 squared plus parentheses negative 3 minus 2 squared. Simplify. Here we've got 5 squared. Here we've got negative 5 squared. And be careful because if you're putting this in the calculator, you do need these parentheses around the negative 5 first when you square it. So that becomes a positive. Negative times a negative is going to be a positive. So we still got 25 plus 25, which will give us 50. And the square root of 50 is 7.1. So that is how to find the distance between 2 points using either the graph or using the formula. Now you will be given some problems where you don't have a graph. So let's take like this guy for example. Number 19, negative 11, negative 2, negative 6, negative 8. You could go ahead and plot this on the graph paper and do the first method. Just count the spaces going across, count the spaces going up. Sometimes, even when I'm doing these problems, I would draw a sketch here. So imagine that this is at negative 11, negative 2. So that means I'm going over far to the left, and then it's going to be down here. So let's just keep in mind that that's negative 11, negative 2. This one's at negative 6, negative 8. So it's not going quite over, not quite as far over to the left, but it's going further down. So it's going to be right there. Okay, just drawing a sketch like this, even if you don't draw the whole system and all the little marks, might help you to find it. Now we want to find this distance here. So I have to think of this as a triangle. Let me move this guy over here. Let me put the coordinates up here at the top. -11, -2. So I want to find this distance. And I can think, okay, how far over do I have to go? Well, to go over, I'm going from -11 to -6. How many spots is it going to move if I go from -11 to -6? Well, you should see that they are 5 away, so that's going to be a distance of 5. And then how far down is that going to have to go? Well, it's going down from -2 to -8. So to go from -2 to -8, how far down did it go? It went 6. So that's one way you can do it. Without drawing the whole graph, you can still make a little picture like this. I know some of you are going to like the formula, so let me do the formula here. But again, you could do it without the distance formula. The distance formula is the Pythagorean theorem in disguise. Again, it looks like this, a big square root, and we got our x2 minus x1 squared plus parentheses y2 minus y1 squared, and we plug in. So x2 is -6 minus x1 is -11. Got to be careful with all these negative signs. y2 is -8 minus y1 is -2. Remember, two negatives are going to give you a positive. Two negatives over here are going to give you a positive. So when you simplify this, -6 plus 11, that's going to be 5 squared. And when you simplify this, this is going to be -6 squared, which is the same as what I have here. I just got it as a +6. And that's going to be the square root of 25 plus 36. Put it into the calculator. Square root 25 plus 36 comes out to 7.8. 7.8 would be our final answer for this one. So that's how you find distance. Okay. I think I went over this before, but again, here are the list of polygons, and you're going to get a picture, and you're going to have to identify it. So a triangle has 3 sides. You're just going to count up the sides and label it. Quadrilateral is anything that has 4 sides. A pentagon is anything that has 5 sides. Hexagon has 6. Heptagon has 7. 8 is an octagon. Nonagons have 9 sides. 10 sides is a decagon, and dodecagon has 12 sides. So you're going to have a picture like this, and then you're going to have to label. So I suggest making a mental mark, or if you can draw the picture and then count how many sides you have. 1, 2, 3, 4, 5, 6, 7. Maybe even put a number next to each side as you go along here to make it easier to keep track. Because the biggest thing is losing track of where you started. So this has 7 sides. It is a heptagon. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides is a decagon. So deca means 10, as in decimal, as in decade. So that is a decagon. This one is a hexagon. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. That is a nonagon. And this one looks like the pentagon. And this one, even though it looks like a square, we're just labeling this as a polygon. So I'm looking for quadrilateral for this guy. All right, in the next section here, we're going to start talking about perimeter, circumference, and the area for different figures. So perimeter is going to be the distance around a polygon. We just add up the sides. So, for any polygon, you can find the perimeter. Just add up all the sides that you have. But we do have some shortcut formulas because rectangles, we know that rectangles are quadrilaterals where the opposite sides are going to be congruent. So these two sides are the same, these two sides are the same. So we have this shortcut, perimeter is equal to 2L plus 2W. And then for a square, since all the sides are the same, we can just take one side and multiply by 4. Now, if we're talking about circles, we give it the name circumference. Circumference is the distance around a circle. So if you take this, loop and you undo it, we are measuring the length of this, and that is called the circumference. And the circumference has a formula 2 pi r, where r is the radius, and pi is that special irrational number that is approximately 3.14, but it's irrational, so remember it goes on forever and doesn't stop or repeat. And the radius here is from the center to the outside. Now there's also a formula, just pi times diameter, because the diameter is all the way across and it goes through the center. But I like to just memorize as few formulas as possible. So if I was to memorize a formula, this is the one that I would memorize, because when we get to the area formula, it's going to use the same numbers just in a different way. So it's still going to use the 2 and the pi and the r when we talk about area. So this formula is going to make it easier to memorize the area formula when we get to that. All right, so you're going to have to find the circumference of each circle, and notice that sometimes I might ask you to use 3.14, sometimes I might ask you to use the calculator value for pi, so make sure you're aware of the directions here. And this one says round to the nearest tenth. So if I'm finding the circumference, I'm going to do 2 times pi times r. So for number 1, I'm given the radius is 10, so I'm going to multiply by 2. Pi, I'm going to use 3.14. Let's put that in parentheses, and r is the radius, that's 10, and we're going to just put that into the calculator. So this one's can actually do by hand, because 2 times 3.14 is 6.28, and then we'll multiply by 10 is just moving the decimal place, so we're going to have 62.8, and the units here would be feet, because we're measuring a length. For number 3, again, we're going to do 2 times pi times r. Now here we're given the diameter, so the radius would be 3. Notice we could just do pi times diameter too, but again, just saying we're using one formula. The radius here is 3, 2 times pi times 3, and we're going to multiply that out with a 6 times pi. Put it into a calculator. I'm using Desmos. 6 pi comes out to 18.8 if I round it to the nearest tenth, and this would be in inches. So that's how we find the circumference for a circle. Okay, we're also going to go over some area formulas. An area is how much space, two-dimensional space, shape contains, and it's going to be measured in square units. So for example, imagine you've got a rectangle, and it is maybe it's 4 inches going this way, so let me draw this up here. So it's 4 inches this way and maybe 2 inches the other way. So I want to know how many 1 by 1 squares are contained inside this rectangle. So if it is 4 inches going across and 2 inches going up, how many squares does it contain? Well, I would just multiply 4 times 2, and I would have 8 square inches, or 8 inches squared. If I've got a square, then all the sides are going to be the same. So if it is just draw this as a 3 by 3. So if one side is 3, then the other side is 3, and then we just square it. 3 squared is 9. We get 9 square inches. The next shape we're going to have is a parallelogram, and notice that it's not length times width, it's base times height. So a parallelogram, remember, it looks kind of like this. It looks like a rectangle that got a little tipsy or something. It's about to fall over. So here is our parallelogram. And we could turn any parallelogram into a rectangle. So notice that, what if I just cut this off here at a right angle, and I take this part and I glue it over here. Then I would have a rectangle, and that rectangle would have this base. So this is our base. It's going to be this length. So the length of the rectangle is this base. And the width of the rectangle would be the same as this height. So parallelogram can be changed into a rectangle, but we can't use this slanty height here. So we can't use this slant height when we're finding the area. We would use it to find the perimeter, but to find the area, we have to use the base and the height, and we have to look at where the base and the height are perpendicular. So just because we call it the base does not mean that it's always on the bottom. We could have a parallelogram, for instance, maybe it looks like this. And maybe this is the height that we know. Okay, and if this is the height that we know, then we have to use this length here for the base. Okay, so just to show you that the base and the height don't have to be the base doesn't have to be on the bottom, but they do have to be perpendicular. The formula for a triangle is 1/2 base times height. So, draw a triangle like this, and if you make another copy of it and you flip it around, any triangle that you make, we can turn it into a parallelogram. So if I take a triangle and I have 2 copies of it, then I can have a parallelogram, and that's why a triangle is half of a parallelogram. And just like with the parallelogram, we need to know the base and we need to know the height in order to find the area for a triangle. And then the area for a circle, like I said, we're going to use that 2 pi r, but here the area is pi r squared. So since we're talking about square units, it's the r here that's going to be squared, and we're going to multiply that by pi to find the area for a circle. So let's look at a few examples. So these are all rectangles. The area of a rectangle is length times width. Pretty easy. We would just do 12 times 6. In this case, it would be 72. The units would be square yards, and that's it. Now, for some of these that you're going to see, the units are going to change. So if you have different units, like here I have millimeters, here I have centimeters, you need to get them into the same unit first. Now, which units? Well, really it doesn't matter, but I suggest going into the bigger unit. So since centimeters is bigger than millimeters, I would change this to centimeters as well. That will make the numbers smaller. So you have less writing to do, less typing to do. So 70 millimeters, remember King Henry died by drinking chocolate milk. If I go from millimeters to centimeters, the decimal has to move 1 space over, so 70 millimeters would be 7 centimeters. Now I can take it and multiply those together. What is 7 times 9.5? Comes out to 66.5, and that would be square centimeters. Okay. Here's some problems where we're going to find the area for a parallelogram. So let's just take number 2 as an example, and let's find the area and the perimeter. So first off, the area. When I'm finding the area for a parallelogram or for a triangle, what I first look for is the square. Okay, you look for the right angle, because that right angle is going to connect to the sides that we need to use. So that right angle, which sides is it touching? Well, it's made up of this side here, and it's made up of this side here. If you have a pen or a highlighter, sometimes it helps to highlight those. And so those are the lengths that we're going to use. Notice that we don't use then the 8.9. We're going to use the 7.8, and we're going to use the 7. So the area is going to be the base times the height. So here the base is 7.8. The height is 7. We multiply those together. 7.8 times 7 comes out to 54.6. And that would be miles squared, because we're talking about area. Now let's do the perimeter. So let me change colors here. For the perimeter, remember for perimeter we just go around the sides and we add them up. So if I start here, this side here is 8.9, and then I go along the top, that's 7.8. Then I go along this side. Oh, that one's not labeled, so what is it? Well, the opposite sides for a parallelogram are equal, so it's not labeled, but this one is 8.9. Then we go along the bottom, that's 7.8. Notice that when we're finding the perimeter, we don't use the height. The height is only used when we're finding the area. But for the perimeter, we're adding up this slanted height, this base, this other slant height, and this base. So we go all the way around. Of course, we could do just 8.9 times 2 plus 7.8 times 2, similar to a rectangle. And here we would have 33.4, and this would just be miles because we're talking about the length. So 33.4 miles. So that's how we find the area and the perimeter for a parallelogram. For number 3, again, we would have to make sure our units are the same. What would the base and the height be for number 3? So remember what I said. We look for the right angle, and then look for the sides that make up that right angle. So it's this side and this side, which is going to extend. And what dimensions do we have? What measurements do we have on those sides? Well, here it's 66 millimeters. Here it's 10.6 centimeters. Again, we want to switch it so it's all the same unit, usually changing to the bigger unit, which is centimeters. So 66 millimeters will become 6.6 centimeters. So we would take 6.6 and multiply it by 10.6 to get our answer for the area. 6.6 times 10.6 comes out to 69.96 centimeters squared. Okay, so now we have some triangles, and remember the formula for a triangle. It is 1/2 base times height. And let's look at number 10 here. So number 10, notice that this is where the right angle is. This is going to be the height. This is going to be the base. So we would just do 8 times 10 times 1/2 or times 0.5. So the area for this triangle for number 2 would be 40 square yards. For number 3, which is going to be the base and the height? Well, look at the right angle. Look at the sides that make up the right angle. So it's this side and this side. So what measurements do we have to use? The 42 inches and the 8 feet. Oh, but they are not the same units, so we have to convert. And we're going to convert to the feet because that's a little, bigger units. We'll make our number smaller. 42 inches, if we divide that by 12, there's 12 inches in a foot. That's going to give us 3.5. So 3.5 feet. Cross that out. And we're going to take 8 times 3.5 times 1/2. 8 times 3.5 times 1/2 comes out to 14. So 14 square feet for that one. All right, through this one on here is a challenge problem. So this one says, find the perimeter and the area for this triangle. And all you're given is that this side is 6 over here, and this side is 8. So how would you find the area? The area is probably easier. So the area is equal to 1/2 base times height, What sides are we going to use for the base and the height? Well, look where the right triangle is, or right angle, and it connects this side and this side. So it's going to be 1/2 times 6 times 8. And if we do that, that's going to be 24. I didn't put units on here, but 24, we'll say that these are inches, so we have 24 square inches. How would we get the perimeter? Well, we'd have to add up all the sides, so we already have 6 plus 8. But now when we go around, we need to find this length. How do we find this length? Well, notice that it's a right triangle. So how do we find the lengths or the sides in a right triangle? We have to use the Pythagorean theorem, 6 squared plus 8 squared. And if we take the square root of that, that will give us our C here. So what does that come out to? It's going to come out to 10. So we add 10 here. And then we got 14 plus 10 is 24. That's going to be 24 inches. So it comes out to the same number, but these are different units, different measurements. One is the perimeter, 24 inches in length, and one is measuring how many little squares fit in it, 24 little squares. Okay. Last but not least, let's do some area for some circles. And here the formula is area equals pi r squared. Again, it's similar to the circumference formula. We got the 2, we got the pi, we got the r, but it's not 2 pi r, it is pi r squared. So we got to remember to find the radius and square it and then multiply by pi. So for number 1, what's the radius? Well, the radius is the distance from the center to the outside. The radius here would be 5. We plug it into our area formula. We're going to have area is equal to pi times 5 squared, or pi times 25, which comes out to 3.14 times 25, 78.5. 78.5 kilometers squared. Again, we're doing area. And just to compare, if we did the circumference would be 2 times pi times r, and that would be 2 times pi times 5, which would be 10 times pi, which would be 31.4 kilometers. Okay, for number 3, we got 18 meters, and that's our diameter. So the radius here is going to be 9. So we have the area is equal to pi r squared. The area is equal to pi times 9 squared, which is going to be 81 times pi. And then we just type that in, see what we get. 81 times 3.14. We get 254.34. And that would be square meters. If we were doing the circumference would be 18, 2 times 9 times pi, or 18 times pi, comes out to 56.5 meters. And I forgot, we're rounding to the nearest tenth, so up here we just do it to 0.3. So that's how you find the area, and again, the circumference for a circle. All right, so that should be it for this next lecture. Let me know if you have any questions, and we'll see you next time. Bye!